Our universe is a vast and mysterious place. It is filled with objects of incredible beauty and power. Stars are some of the most fascinating objects in the cosmos. They are the building blocks of galaxies, and they play a vital role in the evolution of the universe. Stars are born in giant clouds of gas and dust. These clouds are called nebulae. Gravity pulls the gas and dust together. The cloud gets smaller and hotter as it collapses. Eventually, the core of the cloud gets so hot that nuclear fusion begins. Nuclear fusion is the process of combining atoms to create new elements. This process releases enormous amounts of energy. This energy is what makes stars shine. The life cycle of a star is determined by its mass. Massive stars live short, brilliant lives. They end their lives in spectacular supernova explosions. Less massive stars, like our Sun, live for billions of years. They eventually fade away as white dwarfs. But even in death, stars can continue to influence the universe around them. In this essay, we will explore the fascinating afterlife of stars. When a star like our Sun runs out of fuel, it begins to die. It swells up and becomes a red giant, shedding its outer layers into space. What's left behind is a core, still incredibly hot, but no longer generating energy from fusion. This core is a white dwarf. White dwarfs are small, incredibly dense objects. They are about the size of Earth, but can have a mass comparable to our Sun. This means the material inside a white dwarf is squeezed incredibly tightly. A single teaspoonful would weigh tons. White dwarfs shine with a faint, eerie glow. This is the leftover heat from their former lives as stars. Over billions of years, they slowly cool down. They eventually fade away, becoming invisible remnants known as black dwarfs. Although they are no longer fusing elements, white dwarfs still play a role in the universe. Their strong gravity can influence nearby objects. They can even pull material from companion stars, creating spectacular displays of light and energy. If a star is much more massive than our Sun, its death is even more dramatic. Instead of becoming a white dwarf, it explodes as a supernova. This is one of the most powerful events in the universe. The core of the star collapses in on itself. It gets squeezed so tightly that the protons and electrons in its atoms are forced to combine, forming neutrons. This creates an object of almost unimaginable density, a neutron star. Neutron stars are incredibly small, only about 20 kilometers across. But they can have twice the mass of our Sun. Imagine squeezing all the matter in the Sun into a space the size of a city. That's how dense a neutron star is. A teaspoonful would weigh billions of tons. Their gravity is so strong that it warps space-time around them. Even light is bent by their immense gravitational pull. Neutron stars are not just incredibly dense, they also spin incredibly fast. This is because they inherit the angular momentum of their parent star. As the core collapses, it spins faster and faster, like a spinning ice skater pulling their arms in. Some neutron stars spin hundreds of times per second. These rapidly spinning neutron stars have some fascinating properties. Some emit beams of radiation that sweep across the sky like cosmic lighthouses. We call these pulsars. Supernovae are among the most cataclysmic events in the universe. These explosions mark the end of a star's life, but they also mark the beginning of something new. When a star explodes as a supernova, it blasts its outer layers into space. These layers are full of heavy elements that were created in the star's core during its lifetime. These elements are the building blocks of planets and even life itself. There are two main types of supernovae. Type 1 supernovae occur in binary star systems. A white dwarf pulls material from its companion star. Eventually, the white dwarf accumulates too much mass. It becomes unstable and explodes. Type 2 supernovae occur when massive stars run out of fuel. Their cores collapse under their own gravity, triggering a runaway nuclear reaction that rips the star apart. Supernovae are incredibly bright. They can outshine entire galaxies for a short time. They are also incredibly important for the evolution of the universe. They seed the interstellar medium with heavy elements. They trigger the formation of new stars and planets. Section 5. Kilonovae, when neutron stars collide. In 2017, astronomers witnessed something extraordinary. Two neutron stars, locked in a deadly dance, spiraled towards each other and finally collided. This event, dubbed a kilonova, sent ripples through space-time. It created a blinding flash of light and a burst of gravitational waves that were detected on Earth. Kilonovae are even more energetic than supernovae. They are thought to be the source of many of the heaviest elements in the universe, such as gold and platinum. The collision of two neutron stars is a truly mind-boggling event. It is a testament to the extreme conditions that can exist in our universe. Kilonovae are a relatively new discovery, and astronomers are still working to understand these powerful events. By studying them, we can learn more about the nature of gravity, the origins of heavy elements, and the evolution of the universe itself. Section 6. Pulsars, the universe's lighthouses. As mentioned earlier, some neutron stars are also pulsars. These rapidly rotating objects emit beams of radiation from their magnetic poles. These beams sweep across the sky like the beam of a lighthouse. If Earth happens to be in the path of the beam, we see a pulse of radiation. These pulses are incredibly regular. They can be used as cosmic clocks. Pulsars are fascinating objects. They provide insights into the extreme physics of neutron stars. They can be used to study a wide range of phenomena. These include the interstellar medium, the structure of our galaxy, and even the nature of gravity itself. Section 7. Magnetars. Magnetic monsters of the cosmos. Some neutron stars are even more extreme than pulsars. These are magnetars. Magnetars have the strongest magnetic fields in the known universe. These fields are trillions of times stronger than the magnetic field of Earth. The magnetic fields of magnetars are so strong that they can distort the shape of atoms. They can even cause the vacuum of space to become birefringent, meaning that light passing through it is split into two beams. Magnetars are relatively rare. Only a few dozen have been observed so far. They are also very short-lived. Their magnetic fields decay rapidly, and they eventually become ordinary neutron stars. But during their brief lifetimes, magnetars are some of the most powerful and enigmatic objects in the universe. Section 8. Black hole destiny. The ultimate fate of neutron stars. What happens to a neutron star eventually? The fate of a neutron star depends on its mass. If a neutron star is massive enough, its own gravity can overcome the outward pressure of neutrons. The neutron star will collapse further, forming a black hole. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. The formation of a black hole is a dramatic event. It is thought to be accompanied by a burst of gamma rays, the most energetic form of light in the universe. Black holes are some of the most mysterious objects in the universe. They are still not fully understood, but they continue to fascinate and intrigue scientists and the public alike. Section 9. From death, life, the cosmic cycle of star birth and destruction. The death of a star is not the end. It is simply a new beginning. The material that is blasted into space during a supernova or kilonova eventually becomes part of new stars and planets. In this way, the cycle of stellar death and rebirth continues. The elements that make up our bodies were once forged in the hearts of stars. We are all made of star stuff. The atoms in our bodies were once part of stars that lived and died long ago. The iron in our blood, the calcium in our bones, the oxygen we breathe. All of these elements were created in the nuclear furnaces of stars. We are intimately connected to the cosmos. We are part of a grand cosmic cycle that has been going on for billions of years. Section 10. Unveiling the universe, our continuing quest to understand the cosmos. The study of zombie stars is a journey into the extremes of physics. It is a quest to understand the fundamental nature of matter, gravity, and the universe itself. We have learned much about these fascinating objects in recent decades. We have also made many new discoveries, but there is still much that we don't know. What is the precise mechanism that drives supernova explosions? What is the nature of the matter inside a neutron star? How do black holes form, and what happens to the information that falls into them? These are just a few of the many questions that astronomers are working to answer. The study of zombie stars is a vibrant and exciting field of research. It is sure to lead to new discoveries and insights in the years to come. These undead wonders of the universe continue to captivate our imaginations. They remind us of the vastness and mystery of the cosmos. They inspire us to keep exploring and to keep asking questions about the universe and our place in it.